I very much thank Patrick for the introduction. As he said, I don't really have a background in professional cartography, and I like to use the word amateur as an expression of my love for the world of maps, not as a token of professional ineptitude, though I realize that the decision is not really mine to make. Now, though I'm not a professional cartographer, actually my day job does involve maps, and I'm actually one of the persons responsible for map.cz, which is #1 European web map service, probably, and I'm also happy to say a bit of a love mark in the part of Europe where I come from. But our topic today is different, and that's web-based 3D terrain maps. So there's a question, why web-based 3D terrain maps? And my motivation for this is an anecdote. It's about 2 years ago. My daughter was reading a book on the pioneering British explorers of Mount Everest, and she kept coming to me asking all kinds of general geography questions about the Himalayas. And it's always flattering when I have my daughter asking me questions when she can look up everything on Google, but I kind of discovered that there were not so many good online resources on the geography of Himalayas, and the book had some rather lovely monochrome line art maps, but I realized that what my daughter was looking for was something a bit different, something akin to the Eric Knight map of the Caucasus, which came out about the same time. And incidentally, when Tom Patterson, who I'm very happy to see here, praised Eric Knight's work on Twitter, somebody wrote, "I wish I could dynamically create these maps for different regions." And at least one person thought this was a good idea, and I was the other. So if nobody else was doing it, I thought, why not? I'll give it a shot. And so this was the primary motivation for me. The web-based terrain maps actually allowed for arbitrary views. That sounds actually amazingly appealing to me, that we could create something that would not really be that beautiful as those manually curated maps that many of you guys are doing, but that could be basically generated on the fly. We could do this easily. And also, web-based 3D terrain maps would be naturally multi-scale. They would be interactive. And as all things web, they would also give us benefits of server-side storage and processing. And on the top of this, they could be off-the-shelf and portable, and hopefully, I say hopefully, lightweight. So all this seemed good reason. And another reason for me is that there's actually no real reason not to do large area web-based 3D terrain maps, because the technology that allows us to do so, WebGL, has been available and mature for at least 10 years. So I thought that I'd give it a try, and I created this little project for myself to do in my free time, and that was to create an interactive, multi-scale, web-based 3D terrain map of the world in natural color, and to do it with open source software and public domain data. When I say multi-scale, I eventually wanted to go all the way to topographic scale, but that still remains largely a goal. And the reason why I've kind of limited myself to open source software and public domain data is twofold. First of all, I've never really used commercial software in my life, so this would be a natural thing to do. And also, I kind of expected this project will entail modifications of the software, which doesn't scare me because I'm a software developer, and it pretty much proved to be the case. So, and public domain data, well, I think we have sufficient resources for this not to really feel compelled to use commercially available stuff. Also, this is a hobby project for me, so I don't really want to spend money on it. But I did spend quite a lot of time on it. And so the first thing, choice of software. It actually turns out that not only the technology to do 3D terrain mapping is available, but there is actually no shortage of software libraries that you can use to do so. And only discussing these would, and their possibilities and comparing them would fill the time allotted to this talk many times over, so I won't do it. And I will just tell you that what I choose in the end was the most unlikely of choices, VTS Geospatial. VTS Geospatial is an open source 3D streaming, 3D map streaming and rendering library developed by Melon Technologies, which became part of Leica Geosystems in 2019. There are some very compelling reasons to use it for this project. First of all, it was designed bottom-up for planetary scale. Second, it's full stack, unlike pretty much any other system. It means there's no dependence on external and quite often non-free components. And it's also a system I know well, because I actually happened to work in Melon Technologies in the time when the open source release happened in 2017. This was a particularly compelling reason for me. There's also some good reasons not to use VTS Geospatial. First of all, it takes a Unix system professional to operate. It's quite a funny thing, because we always wondered in Melon Technologies why there was not a community around it. And it turned out that there's not so many Unix system professionals that have a knack on cartography. So, yeah, there's no community to speak of for this particular reason. And sadly, it's no longer active or maintained, because since the acquisition by Leica, it looks like Melon Technologies has slightly different priorities. There's also some implementation oddities, which have been kind of depriving me of sleep since I started on the project. Well, I don't really want to talk about it. And yeah, so on to data sources. I use the natural earth for natural color and texture at small scale. Yeah, natural earth was actually an important resource for me, as will be seen later. And because I needed a lot more detailed land cover data, I used ESA world cover, which Jesse already mentioned here. It's an excellent data set by the European Space Agency at 10-meter resolution. I used the Viewfinder Panoramas DEM for terrain, which is done by Scottish geographer Jonathan De Ferranti. It's basically a SR derived product, which is largely free of errors, which was important to me. And I used or plan to use OpenStreetMap for lettering. The first challenge I needed to address was shaded relief. Now, naive approach to actually doing this would be to pre-generate a static analytic shaded relief at full resolution. That's certainly doable. These are large data sets, but this is nothing prohibitive. However, there's issues that some of them are familiar and some of them are unique to the 3D realm. One of them that's probably familiar to you is that shaded relief does not really lend itself to downscaling, so you actually need to do this for any of the map scales. The other problem is the contre-jour or adverse backlighting. If there was only one static shaded relief, then since this was an arbitrary view product, once you look at your terrain from another angle, you get these adverse backlighting effects. So what I did was that I modified VTS Geospatial and I implemented on-the-fly multi-scale shaded relief rendering with multiple illumination vectors at each scale. And then, at the time of rendering, did the view-dependent real-time blending of shaded relief textures. This is kind of convoluted, actually. It would probably be a lot more easier just to do independent lighting, but that would actually require me to massively modify VTS Geospatial, which I did not really have time for. So I did this kind of a hack. And it turned out actually fairly nicely, which is demonstrated here by 3 random views of the same area, and which get something that doesn't really have the adverse backlighting effects I was talking about. Second challenge was 3D vertical exaggeration. In a manual produced map, this would be an opportunistic decision based on multiple considerations, usually such as scale of the map, prominence of the terrain, and the importance of the terrain in the hierarchy. But this is an automatically generated arbitrary multi-scale map, so I needed some sort of a mathematical abstraction. I love mathematical abstractions, so I came up with this. basically the 3D vertical exaggeration, which is used as a function of map scale. It obviously increases with the decreasing scale of the map. The relation is exponential or linear in the logarithmic scale, as is demonstrated. So in my map, the vertical exaggeration would go from something over 1 for larger scale maps all the way to about 16 for planetary scale views. So this is the demonstration of what it actually leads to. The same area, 4 views going from 350 kilometers all the way to 22,000 kilometers, and the vertical exaggeration going from 1.31 to 907. Since this is an interactive map, this actually creates some interesting effects of the mountains popping out as you zoom out. I kind of dislike these effects because I find them distracting. So I was, in the end, I put in a little bit less vertical exaggeration than I originally wanted to. For the land cover texture, I took a very rudimentary approach. There's 11 land cover classes from ESA World Cover that were assigned flat color tones that I choose to closely mimic natural earth 1. This has been an interesting exercise when I say that I choose them to closely mimic natural earth 1. I actually didn't choose them. The program I wrote chose them. And they look very uninspiring, actually, but this dull colors in the end were exactly what was needed to give me a very consistent look across the map. What's noticeable is that the built-up areas are largely suppressed, which I found okay, because this was meant to be a physical map to start with. And so what you see on the left is natural earth 1, well, minus the water, I choose the water. And on the right side, you actually see the world cover map, which has a much larger resolution, 200 times actually, but which is virtually unrecognizable from, well, I mean, you can recognize it, there are some differences, but to me this was a very pleasing result, because actually that similarity of tone allowed me to directly use natural Earth data at small scale. Normally a big problem in 3D mapping, because when you combine non-consistent data sources, then you get all kinds of weird transitions. And I was allowed to do this because this actually came up so similar. So in the end, the land cover texture that you see on the left, combined with the dynamic shaded relief to give me something like this, which is the current state of the map, I'd say, the instantly recognizable view of the Alps. So I put up a website where you can actually see the current state of the map. I can see you're looking at your handhelds. WebGL tends to get very intensive on your resources. and also, since the server is hosted in London and everything is dynamically generated, I ask you for patience with the initial load of the map. It might take up to 20 seconds to happen. But after that, you should see something, hopefully, interesting. Oh, sorry, I meant to show you this. Your feedback is very much appreciated. You can write me at the address or use the Twitter. Nobody seems to be using Twitter or X here anymore, but there's got to be a reason for that. But yeah, I'm still there. And I'd like to say also that this is very much ongoing work. I'm only getting started. This is just first I need to improve the performance. I very much like to improve the natural colors because I find them much less expressive than I'd like them to be. Improved lighting model, that should be very nice. Aquafication, I'd like to do the full bag of tricks in Tom's excellent 3D terrain map tutorial on the web, basically. And atmospheric perspective. And of course, lettering, where I'm missing an R, which kind of demonstrates that I really didn't give it any attention yet. But yeah, I did some first steps on lettering, but it's just a very, very, very first effort. The lettering capabilities in VTS Geospatial are actually a bit of a mixed bag, and this will take lots of work to be meaningful. And yeah, so some acknowledgements, Tom Patterson, of course, because I would never do this, Tom, without your making 3D terrain maps tutorial. It's actually something that made me feel that it's something that I should venture into. Vašek Blažek and David Lavinsky and people at the Mount Technology, because those are the guys who wrote VTS Geospatial, and I would never do it without them as well. And of course, my company that actually gives me time and money to travel here. So, so yeah. So that's it from my side. Once again, I appreciate your feedback, and I'll leave it there. Well, frankly, I don't know. Because, yeah, the question was that in the land cover scheme, I employed moss and lichen, and at what scale and at what point it would be seen. And my answer to this is that I don't really know, because basically the entire I use all the classes which were present in SL land cover. And the colors were assigned by the linear regression, which was there to mimic the colors of natural Earth as closely as possible. But I can look it up. I think that this is a class which is fairly lowly represented in the ESA world cover data set. But I think that it's actually present in the mountain ranges, in the transition zone between grassland and ice. So yeah, so that's where I would look for them.
Any other questions? All right.
Okay, thank you.
Is that your thing? Yeah.